Welcome to the screencast on converting fractions to decimals. To get started, let's take a look at a fraction written as a numerator over a denominator. Now, a fraction does not only mean a number that represents parts of a whole, it actually represents a division problem as well, where I'm taking the numerator and dividing it by the denominator. Another way I could represent that is thinking of how many denominators fit into the numerator, which if I wrote that in long division form, I would have my denominator going into my numerator. So watch out, because when we show it in long division, all of a sudden the order switches. Now let's use that definition and try an example. I'm going to take 11/25 and I'm going to convert that fraction into a decimal. So that means not only 11 parts of 25, but it means 11 divided by 25, or how many 25s fit into 11. Now I can't fit a whole number of 25s into 11, but if I introduce a decimal point here and here, and I bring in some of my zeros that exist to the right of that decimal point, I can now start thinking of this in terms of larger numbers like 110. How many 25s fit into 110? I know that I can fit 4 groups of 25 into 110 with 10 left over. So I'm not quite done because I have a remainder. I had introduced an additional 0 up here in the hundredths place. So I'm going to bring that down. And now I want to go 25 into this 100. Again, now I know 4 groups of 25 will fit in there perfectly. I will have no remainder, and I've converted this fraction into a decimal. In fact, I want to use this moment to point out that because we were able to get to a specific place value with no remainder, this is called a terminating decimal. That means that the place values of this decimal number end in a very specific spot. They end right there in the hundredths place. Now, not all decimals will be terminating decimals, so let's take a look at an example of one that's not. And instead of doing a proper fraction, I'm going to grab an improper fraction. So let's look at 13/6. I happen to know that this will not be a terminating decimal just from prior experience, and you'll see why in a moment. So this means 13 divided by 6, which is the same as asking how many 6s can I fit into 13. Well, in this case, I know that I can fit some. I can fit 2 groups of 6 into 13 with a remainder of 1. Because 2 groups of 6 is 12. So I need to introduce my decimal point and consider bringing in some zeros to the right of the decimal point. I'll go one at a time. So we'll bring that 0 down. Now I want to think about 6 going into 10. It's going to happen once with a remainder of 4. So I'm not done. So I need another 0 in the hundredths place. I'm going to bring it down here. So now I want to think 6 into 40. It's going to happen 6 times, because 6 groups of 6 is 36. That's going to leave me a remainder of 4. I'm going to pause here because I noticed something important. I got a remainder of 4 2 times in a row. So what do you think is going to happen if I put a 0 in the thousandths place, bring it down, and try this process again? I'm going to get another 6 groups of 6 fitting into 40, which is going to leave me with yet another remainder of 4. This is a good place to stop because this is just going to keep on happening. So 13/6 equals 2.1666666, and so on. A few ways I could handle that. I could represent that number as 2.16 with the bar over the 6. That means the 6s are just going to keep on going. Or let's say I'm working with some sort of contextualized problem where this is, I don't know, maybe 6 friends trying to evenly pay a $13 bill, right? That means we each need to pay about $2.16. I actually have to do some rounding up. Someone's going to have to pay 17 cents. So you could deal with it that way as well, rounding it to a specific place value, in this case the hundredths. So this is an example of a repeating decimal because the digits don't terminate in a definite place value. Right? They only terminate in a place value if we round it off to this place value. But this means that this number is not exactly equal to 13/6. It's approximately equal to 13/6. Now I keep using the phrase place value. That can actually help us out here. Long division is not the worst thing ever. It's not my favorite thing, but it's not the worst. We can actually use place value to help us convert any terminating decimal, or any fraction that is a terminating decimal, we can do that without long division if we have a strong understanding of place value. Here's what I mean. I'm going to take 11/25 again. Instead of doing long division, I'm going to see if I can turn that into hundredths, because I know that this decimal terminates in the hundredths place. So if I scale this fraction up by 4 in the numerator and denominator, I get 11 times 4 is 44, 25 times 4 is 100, and this fraction is 44 hundredths. Well, the proper way to read this decimal number is 44 hundredths, not 0.44, even though that's how a lot of us read it. So 44 hundredths, back up here, translates exactly into 44 hundredths in decimal notation. So one more just quick follow-up regarding place value. If I have a decimal point here, and I've got some numbers on either side of that decimal point, this right here, that's the ones place, tens place, hundreds place, right? These numbers are getting bigger. If I go to the right of my decimal, the numbers are going to get smaller. I'm going to have the tenths place, the hundredths place, the thousandths place, and so on. So what this number says is that I've got 44 hundredths. I've got a 4 in the tenths place and a 4 in the hundredths place. So that's a little shortcut that can help you avoid using long division. But long division will always work in a pinch. It'll work with terminating decimals and with repeating decimals. This has been my screencast on converting fractions to decimals. Thank you for watching.